Hi all, welcome back to my YouTube channel. Before we have a look at one more numerical from joint probability, I would strongly request you to subscribe to my channel, share with your colleagues, students, which you may think it can help them. So let's have a look at the numerical from joint probability. So the situation is like there is one box containing 5 yellow balls and 3 red balls. So 4 balls are drawn without replacement. So let me write without replacement. So this is a experiment. Now there has been event defined. Outcomes are which also have been defined in some way. Let's have a look. So X is a X is a random variable which has been defined like it's a number of yellow balls in first two draws, and Y is total number of yellow in all four draws. So this is a way X and Y are defined, and we have been asked to plot a joint probability function with these two variables. So let me write what all possible values capital X can take. Let's call that as X, and let's call small y representing what all values capital Y can take. So given X is a number of yellow balls in first two draw, in first two draws, when we are drawing a ball from the box, we can have 0 yellow balls, 1 yellow ball, or we can have 2 yellow balls. Similarly, with Y, when we are it represent total number of yellow balls in all four draws. So let's see what possible values Y can take. So bear in mind that Y cannot take Y zero value because there are only 3 red balls, and total balls that we are drawing is 4. So even if we get 3 red balls in first three draws, we will have certainly 1 yellow ball. So minimum value Y can take is 1, and likewise it can take 2, 3, and 4. So we have been asked to calculate the corresponding probability of these boxes. So eventually, like we had to calculate f of 0, 1, f of 1, 1, f of 1, 2. I'm just changing a row, like I'm changing x variable, or let me plot in some better way. So let's see if when 0 fixed and y vary. So f of 0, 1, f of 0, 2, f of 0, 3, and f of 0, 4. So this is a value, I have fixed the value of x, and y varies. Similarly, when x is 1, y is 1, x is 1, y is 2, x is 1, y is 3, x is 1, y is 4. And likewise, last possibility would be x is 2, y is 1, x is 2, y is also 2, x2, y3, x2, y4. So basically all the possible outcomes that we have to find the respective probabilities. But bear in mind, we can find the probability only if they exist. So there are some event like this particular, if I talk about this particular box, it says 2 yellow balls in first draw, and total number of at the same time total number of yellow balls in all four draws is 1, which is not possible because at the same time you're saying you have 2 yellow balls in the first outcome, and you're saying that total number of outcomes in all four draws yellow balls are 1, so which is not possible. So these events won't be possible. So let me in with a similar argument we can put uh, fill the boxes which are not defined. So we will say NA, this particular box is not possible. And similarly, this is not possible. You are saying that in first two outcomes you have zero yellow balls, and at the same time you are saying you have total three yellow balls in all four tries, which is not possible. With a similar arguments, you can make statement and see that these two are also not possible. So with the same argument, so these were the only boxes wherein probability will not exist, and rest we will find how we can see. So first I'll show you how to find the probability of F01, and I'll fill the boxes, and you can take the remaining as a practice. It's slightly easy but a bit lengthy. Let me add one more page and we'll go back to the prior one once we have the probability. So say for example, I have to calculate probability of F01. It means that in your first two draws, there are zero yellow balls. In first two draws, and total number of yellow balls in the all four, total yellow in all four draws is 1. Now let's see how it's possible. So there are no yellow balls in first two draw. If I consider this to be 0, that means when I say x is 0, that means there are no yellow balls in first two draws. So what will happen that the only possibility that remains over here, let me draw balls. Okay. So only possibility that is left out when I say x is 0 is that you have red ball in first outcome, red ball in second outcome. And when I say yellow is 1, either of this box has got the value yellow. So say for example, in a first possibility, I'm saying this particular third draw has taken red and last one is yellow. And with the same argument, what I'll do, there is another possibility for this 0 1 only. So when you say your first draw is red, second draw is red, it also means that x is 0. But if your third draw has white and fourth draw has red, I just flip this, and this is a odd situation. So what we'll do, we'll calculate the probability of these four, add up the probability of these outcomes. So let's see what's the probability of having one red. I'm focusing on this. So having one red, there are total three red balls out of eight. So there is a possibility of 3 over 8. Now given one has been already drawn, so there are only two red balls left in the box and total balls are 7. So it would remain as 2 over 7. And similarly, we know that two red balls are already out. So total box has 6 balls and one red. So the probability of red is 1 over 6. Now total balls that are left out in the box are 5, and we have 5 yellow balls in the box. So the probability of getting this is 5 over 5. Similarly, so we'll multiply this and add up this multiplication. Similarly, so these with a similar argument, we can have 3 over 8 for this and 2 over 7 for this. For yellow, now total balls that are left in the box are 6, and there are 5 yellow balls. So the probability of getting yellow ball is 5 over 6 because yellow is favorable outcome and total number of outcomes is 6. And over here, the probability of red ball again is the total number of balls left in the box are 5, and the one red ball is there in the box given the two were already drawn. So the probability will become 1 over 5. Now let's multiply and add these up. So that will correspond to probability of F01. So your F01 would be equal to 3 by 8 into 2 by 7 into 1 by 6 into 5 by 5 plus t over 8 into, I'm just multiplying this, 2 over 7 into 5 over 6 into 1 by 5. So let's see. So this 5 and 5 will get cancelled. 3 to the 6, and there is a denominator in the 6. So these two will get cancelled. So in the first portion before plus, we have 1 over 56. Similarly, like over here, 5 over 5 will get cancelled. 2 3 are 6. 6 will cancel. So it would be equal to 1 over 56 plus 1 over 56, which will be equal to 2 over 56. We can write it as 1 over 28, but just in order to keep denominator consistent with other outcomes, we can just write over here as 2 over 56. So probability of this 0, 1 is 2 over 56. In a similar pattern, you can find the remaining boxes. You will get 2 over 56 over here, and 4 over 56 here, 16 over 56 here, and 4 over 56 here. I have solved it. You can solve it in a similar way. There is no change in the pattern. 12 over 56, 12 over 56, and this is 4 over 56. So you can just add up and see that wherever we have probability, it's summing up to 1. So we can see that 2, 2, 4, 4, 4, 8, 8, 16, 24, 24, 4, 28, 28, 12, 40, and 40, 12, 52, 52 plus 4, 56, and denominator is already 56. So total probability distribution is summing up to 1. That means we have done it correctly. You can likewise try to plot all these probabilities. Like if I were to calculate f0 to, like you can see the probabilities and calculate the remaining boxes. Video have been too lengthy, otherwise I would have solved it. Still, just try to solve at your end. And if any difficulties, please free to comment in the comment box. I will take that up in my next video. If any particular box you want me to take in the next video, I'll be happy to help. Hope you liked the video. If yes, please do share with your colleagues and students so that it can help them as well. Thank you very much. Stay connected.